right, guys, so what we're doing today is finishing up the review sheet, and your test is going to be tomorrow.
No, you can't do that, cuz. Make him ACT tomorrow.
So, this is where we finished up on Wednesday, because this is where we stopped. We looked at these here. Now, we worked through, yes, how to solve these here by hand. And we also saw that the TI-30XS, the yellow calculators, will actually do these for us. So we could plug these into the yellow calculator and they would give us the answer. Now these here are not going to show up on the test, so we're not going to worry about those. So the next set of problems that will show up on the test are these here, are f plus g of x, f minus g of x, f times g of x, and f divided by g of x. Yep. So 25 through 30, these here are not going to show up. But 32, problem like 32 will show up on the test. F plus g of x is what we're going to look at first. Now, f plus g of x is the same as f of x plus g of x. We're going to add the two functions together. Now, our f of x function is going to be our 4x to the 5/4. So we're going to replace f of x with its function. Now, g of x is our 2x to the 1/2. So we'll replace that there. Now, for us to be able to add or subtract, the variables have to be the same. And x to the 5/4 is not going to be the same as x to the 1/2. Those are not the same exponents. So that right there is f plus g of x. So if the exponents with the variables aren't the same, we can't add them. Any other questions or any questions on f plus g of x? Okay. Let's look at f minus g of x. Well, our f minus g of x is the same as f of x minus g of x. And again, f of x is still 4 times x to the 5/4. But this time we're going to have minus our g of x, which is our 2x to the 1/2. So if we weren't able to add them together, are we going to be able to subtract them? Because we can only add and subtract like terms. X to the 5/4 and x to the 1/2 are not like terms. So that's all we have to do for addition and subtraction. Any other questions on this here? So we're halfway done. The next part is going to be our f times g of x. Now this here is saying that we're taking f of x and multiplying it by g of x. Now our f of x function is our 4x to the 5/4, and we're multiplying it by 2x to the 1/2. Now for us here, we can multiply the 4 and 2. 4 times 2 is 8. And when we multiply like bases, when we multiply x to the 5/4 and x to the 1/2, we add the exponents. So we have 5/4 plus 1/2. Now we can do 5/4 plus 1/2 in the calculator. Because for us to add, we have to have like bases. And if we plug that in, we would get 7/4. So for f times g of x, we get 8x to the 7/4. And that's all we would need to do for this here. We got it. One more. Any other questions on f times g of x? Now the last one that we have is f divided by g of x. F divided by g of x. Well, this is the same as saying f of x divided by g of x. Well, our f of x function is 4x to the 5/4. our g of x is 2x to the 1/2. And we're going to divide these here. Now the first thing we can do is 4 divided by 2, and 4 divided by 2 is 2. Now when we divide like bases, when we divide the x's, we're going to subtract the exponents. So we're going to have 5/4 minus 1/2. Yes. Which would be 2x to the 3/4. And that's all we'd have to do for this here. Any other questions on the addition, subtraction, multiplication, or division? Mm-hmm. No. Any other questions on this one here before we move on to the next one? Questions? Now, we're not going to worry about 33 and 34. 33 and 34 will not show up on the test. Because, again, these aren't any more difficult than what we just did. They're just time-consuming. So we will look at one of these or two of these here. Are there questions on 35 through 41? One of these, or 35 through 38? One of these that we want to look at. 35, 36, 37, or 38? 35. Okay. So with any of these composite functions, we want to work from the inside out, taking it one step at a time. So when we look at this here, the first part of the function we're going to look at is g of x. And g of x for us is negative 2x plus 5. So we'll replace g of x with its function. So we'll have f of negative 2x plus 5. Now f of x is 7x minus 2, but I don't have f of x anymore. I have f of negative 2x plus 5. So every place where there's an x in our f of x function, we're going to replace with negative 2x plus 5. So what that'll give us is 7 times negative 2x plus 5 minus 2. And now we'll just need to simplify. The first thing we'll do is multiply through by 7. 7 times negative 2x is negative 14x. 7 times 5 is going to be plus 5 minus 2. If we combine like terms, our 35 minus 2 is going to give us plus 33. So we'd get negative 14x plus 33. Any other questions on 35? Any questions on 36, 37, or 38? 38. G of x. Now again, we're going to start from the inside out. So we'll start with g of x. Now g of x is our negative 2x plus 5. Now with the one that we just did, we took the negative 2x plus 5 and plugged it into f of x because we were talking about f of negative 2x plus 5. Now here we're talking about g. So instead of starting off with 7, we're going to start off with negative 2 times our negative 2x plus, because this time we're plugging the negative 2x plus 5 into g of x, not f of x. So it would give us 4x. Negative 2 times 5 is 10 plus 5, which will tell us that we have 4x minus. And that's it. Questions on any of this here? Any other questions on these 4 problems here? 35, 36, 37, or 38?
37.
So f of x, well, f of x is our what? 7x minus 2. Now, so we replace the f of x with what it is, 7x minus 2. Now we're going to plug the 7x minus 2 into f of x. So we're replacing every x in f of x with 7x minus 2, which would give us 7 times 7x minus 2 minus 2. Now we can distribute the 7 times 7x, which would be x minus 2, gives us 49x minus 16. Any other questions on these here? Questions on 39, 40, or 41? Okay.
Yeah, why there's so many things? I'm just going to leave that one out on the test, all right?
So, again, with any of these here, we're going to start from the inside and work our way out. So, we have g of f of g of f. Now, the inside one is g of, so we're going to plug 3 into g of x. So, we would have negative 2 times 3 plus 5.
Why do they got 3 of those?
Because we're going to do the function each time. Because, again, we're working from the inside out. So, we plug 3 in first. Well, can we type negative 2 times 3 plus 5 into the calculator? Yeah. Because negative 2 times 3 is negative 6, plus 5 gives us negative 1. Well, now what do we have in the inside? F of negative 1, yes? So, okay, so g of f of, so we're going to plug negative 1 into f of x, which would be 7 times negative 1 minus. Now we just need to simplify. 7 times negative 1 minus 2. And again, we could type that into a calculator. Well, 7 times negative 1 is negative 7, minus 2 is. Now what do we have? G of negative 9. So we're going to plug negative 9 into g of x, which would be negative 2 times negative 9 plus 5, yes? And again, at this point here, we could type that straight into a calculator. Do negative 2 times negative 9 plus 5. Well, negative 2 times negative 9 is negative 18, plus 5 is 23. Well, now we have f of 23. So we'll plug 23 into f of x, which will give us 7 times 23 minus 2. But again, we can type that in. 7 times 23 minus 2 will give us 159. And lastly, we'll plug 159 into g of x, which would be negative 2 times 159 plus 5. gives us negative 313. 313. That's it. On this here, all we're doing is just plugging one number into the function and just doing it over and over again. Yep. But overall, the process of what we're doing is not overly complicated. It's just long. That's it. Because we're just taking one step into the next. Questions on this here? Any other questions on 39, 40, or 41? Questions on 39 or 40? Because those are going to be the exact same as 41, just not as many steps.
Yeah, that's the way it is.
We're not going to worry about finding the inverse because I'm not going to ask you to find the inverse on the test. So we will look at solving. Questions on 44 or 45? Yeah, so we can, 44. So the first main step in solving these radical equations is to get the radical by itself. So looking at 44, is the radical by itself? Yes. So that means we could put both sides to the nth power. So for us here, we would put it to the second, because since we're talking about a square root, we would need to square. Because this squaring a square root will cause those to simplify, telling us that 2y is equal to. Now that the radicals have been eliminated, we just need to solve for the value of y by dividing by 2. So this tells us that y is equal to.
Not bad.
And that's it. Okay. Any other questions on 44 before we look at 46? 46. Looking at this problem here, is the radical by itself? No. So what's the first thing we can do to get the radical by itself? Subtract 27 from both sides. So here 27 minus 27 is 0, telling us that 3 times the square root of 2x plus 7 is equal to negative 23. Is the radical by itself?
No.
No. What do we need to do next to get it by itself? Divide both sides by 3. Because here 3 divided by 3 is 1, telling us that the square root of 2x plus 7 is equal to negative 23 over 3. Is the radical by itself now?
Yes.
Okay, so what can we do next? We can square both sides. Because to simplify the radical, we need to put both sides to the nth power. And here the nth power would be 2, because a square root and square will cancel out, telling us that 2x plus 7 is equal to 9. Because 3 squared is 9, 23 squared is 529, yes. Now we just need to solve for the value of x.
Add.
So subtract 7, which will give us 2x by itself. So we can do 529 over 9 minus 7, which gives us 466 over 9. And last but not least, we need to divide both sides by 2, because again, we need to get x by itself. So it'll tell us that it's 233 over 9. And if we plug this back in, we find out that that doesn't work. And the big giveaway for that there is really this part here. We said the square root equals a negative number. We can't have the square root of a number coming out as negative. So it doesn't work for this one here. There won't be one like this here where we end up getting a no solution.
So we just did that.
But those are the steps that we would do to solve it. There won't be any that will give us a no solution. There will be some that we do have extraneous solutions. One of them won't work. But in the instructions for those there, it's going to say in all caps, check your solutions, check your answers. Because one of them might not work. Now, because we did the addition, subtraction, just doing addition, subtraction, and multiplication, division doesn't guarantee that it won't work. But these are the processes that we would do in that situation. Any other questions on 46? Questions on 47? If there are no questions on 47, are there questions on 48 or 49? Are we good with 48 and 49? Okay. Questions on 50 and 51? S minus 1, yes. Yes, sir. We got them last Monday, I think. Let's go and look at 50. Now, number 50 is the radical by itself. So we can put both sides to the second power because it's a square root. Now, on the left-hand side, the radical and square will cancel out, giving us 3 minus s is equal to what? Well, s minus 1 squared is saying that I have s minus 1 times s minus 1. We can't just square the s in the negative 1. This is being multiplied by itself. Now we have to distribute this out. S times s will be s squared. S times negative 1 would be negative s. Negative 1 times s is going to be negative s. And negative 1 times negative 1 is going to be plus 1. Now at this point here, we can combine our like terms, telling us that we have s squared minus 2s plus 1. Anytime the degree of the polynomial is greater than 1, so we have an s squared, we do need to get this equal to 0. So one of the first things we can do is subtract 3 from both sides. And when we subtract 3 from both sides, we'll get that negative s is equal to s squared minus 2s minus 2. We'll also need to add s to both sides. And when we add s to both sides, we'll get that 0 is equal to s squared minus s minus 2. So we need to get this equal to 0 because we have the s squared term. Now at this point here, we can graph this to see what values of s would make this equal to 0, or we can factor. Now if we factor this, our two sets of parentheses, since the 2 is negative, it means our signs are going to be opposite. The factors of s squared are s and s. And the factors of 2 that we want are 1 and 2. That's the only factors. And we would need the 2 to be negative. And if we check this here, s times negative 2 would be negative 2s. 1 times s would be plus s, which gives us a negative s, which is the middle term that we wanted. So we're going to go on and finish this out. So we have two things multiplied together equal 0. So one of them must be 0. So it's telling us that either s plus 1 is equal to 0 or s minus 2 is equal to 0. For our s minus 1, we can subtract 1 from both sides, telling us s is equal to negative 1. For the other one, we can add 2 to both sides, telling us s is equal to 2. Now this one here, it's going to be good to check our answers, plug them back into the original equation to make sure that they both work. As our original equation was s was 3 minus s is equal to s minus 1. Now our first solution that we got was negative 1. Square root of 3 minus negative 1 is equal to negative 1 minus 1. Now at this point here, we could type each individual side into the calculator. So we could type in the square root of 3 minus negative 1, and the calculator will tell us that it is 2. Now negative 1 minus 1 would give us negative 2. And since these aren't the exact same, we can say that s equals negative 1 is an extraneous solution. Now if we work this out, it would actually just tell us the square root, not 2, but 4 is equal to negative 2. Square root of 4 is 2. Now our other one would be taking the square root of 3 minus 2 is equal to 2 minus 1. Well, the square root of 3 minus 2 would be the square root of 1 is equal to 1. Square root of 1 is 1. So s equals 2 would be our solution. Now the problem that this would be on would be the one that says check your solutions. And again, there are points in that section for checking your solution. So you will need this as part of your answer. You will have to check your answer if it says to check your answer. I am assigning points for you checking your answer. Any other questions on this problem here? So any questions on 50 or 51? Are we good with 50 and 51? There won't be one like 53 on the test, but are there any questions on 52? If we're good with problem number 52. Questions on 56 or 57? So again, we need to get the radical by itself. So the first thing we can do is subtract 6 from both sides, which will tell us that the 6th root of 9x squared plus 49 is equal to negative 2. At this point here, we can stop because there's no way that an even root can. Because we can go through the rest of this problem and find the solution, but at this point, it's not going to work. If we were to finish this out, the next thing we would do is put both sides to the 6th power.
Yeah, 'cause you can't have a what's it called, right?
A negative here. Now that would give us 9x squared plus 49 is equal to, because we're looking at 2 to the 6th, is 64. Now at this point here, we can subtract 49 from both sides, which would tell us that 9x squared is equal to 17, 15. Then we would divide both sides by 9, telling us that x squared is equal to 5/3. And last but not least, we can take the square root of both sides, telling us that x is equal to plus or minus the square root of 15 over 3. But again, at this point here, neither one of those solutions is going to work out for the overall problem. But that is the solution steps that we would go through to get to the answer, if it did work. Any other questions on this here? And again, there's not going to be any asking us to find the inverse, but there might be a bonus asking us to show that two functions are inverses. And to be able to do that, we're going to need to show that f of g of x is the same as g of f of x, or more specifically, that they come out to be x. And we can look at this one here. So the first one we want to look at for this is f of g of x. Now for our function here, g of x is our x squared plus 3 divided by 7. And we're going to replace g of x with its function. Now at this point here, we're going to plug this into f of x, which would give us 7 times our x squared plus 3 divided by 7 minus 3. Now when we do the multiplication, it's going to work out that this 7 and this 7 are going to cancel, telling us that we have the square root of x squared plus 3 minus 3. Well, 3 minus 3 is going to be 0, leaving us with the square root of x squared, and the square root of x squared is x. So that's half the problem. The other half is doing g of f of x. Now our f of x function is the square root of 7x minus 3. And that's our f of x function. Now we do have to plug this into g of x, which would give us the square root of 7x minus 3 squared plus 3 divided by 7. Now here the square root and square would cancel, telling us that we have 7x minus 3 plus 3 divided by 7. Well, the negative 3 plus 3 is 0, telling us that we have 7x over 7, which is x. And since both of these came out to equal x, it means that they are inverses. And that's everything that will be on the test. Now, if you don't still have assignments out, either turn them in by the end of the day tomorrow or the end of the day Wednesday. I will give you 2 more days to get those turned in. Have a good rest.